हेलो एवरीवन, इस वीडियो में हम डिस्कस करेंगे अबाउट द मेल्ट फ्लो इंडेक्स नियो 2.0 मॉडल. We have already made a video on melt flow index digital model where with the manual system we are performing the test. Here we are performing the melt flow index or melt flow rate analysis in a more advanced manner where we will be having a profile and the reports will be generated through it. The calculation is automated. So these things we are trying to see in melt flow index neo 2.0, that how it can help in handling the fast or the testing in more accurate manner, because and it will help us to handle the things and the manual interventions in this, and those things will be neglected in this. So the thing we are doing in melt flow index tester, here we have this kind of HMI screen, and this is the section where we will be having our inbuilt weighing balance, where it will be used for doing the automatic calculation of the cut pieces we will be getting from the die. First of all, the purpose of melt flow index tester is to check the melt flow rate of the sample, that we all know. The advanced features here will be having that it will automatically detect those results after we will feed the sample, so that we will see, which will help the molding industries, the injection molding, to apply the temperature, time or the pressure parameters perfectly as per the grams per 10 minute, the flow rate of the sample. So that's why, to check the quality of the granules, mainly the polymers, this particular equipment is used. So we will go in the program profile section. We have password protection in this, and sample ID, test method, the description of samples can be given, and now we have to apply the weight. So machine complies to ASTM D1238, where the temperatures, the weights has to be are provided for specific polymer grade, either it is HDP, PP, ABS, POM material. So any kind of material has a specific weight and temperature to be fed. So that I'm setting here as 2.16 for this weight, and temperature for the sample which right now I'm using is a polypropylene, and it takes 230 degrees Celsius. Test time I have fed. The test time is basically dependent on how fastly from the die the sample is coming out. So accordingly, if the flow rate is high, we need to accordingly set the time as 30 seconds or 40 seconds. Right now I'm setting 60 seconds for it. Okay, so that you will understand by looking at one cut piece at least. Okay, so that we can set here. After that, preheating time. In some of the machines, preheating facilities are not available, and it is a very important feature. For example, if I talk about nylon 66, and if we will provide some 25% of glass fiber in this, let's say composite thing we are doing, so in that cases it can make the sample hygroscopic. So it is important that the sample has condition is properly conditioned before starting the actual test. So for that, preheating time is required to make the sample conditioned. So that preheating time we can set 2 seconds, 3 seconds, or whatever time you want, that you can set here. So here right now in the polypropylene there is no moisture, that's why there's no specific requirement for preheating, that's why 2 seconds is enough. Manual cutter time we have, because right now we have auto cutting facility in this, so manual cutter doesn't need it to be set here. The number of test cycle, how many cut pieces you want to get calculated, that you can set here. And right now minimum, maximum and maximum MFI, those things I have set 2.7 to 13. Accordingly the pass fail will be decided. That industry can set as per their application specific things. Now we will go in the test mode, and we need to start the test by feeding the sample. This is the section where we need to feed the sample. The amount of sample we feed in the barrel doesn't define that how much result we will get. So we can feed any number of sample, amount of sample. So the main thing is that the barrel diameter or the length should be as per what standard says, 115 to 180 mm, and 9.5 is the requirement of the diameter. The bore size, if I say, it's defined that it has to have a 2 mm as the dia of that orifice, and length has to be 8 mm. So those things are defined, and then we can perform it. This is enough. Now we need to use press tool to release the vacuum, and air bubbles will not form in due to this, and you will get a proper sample. This is how standard defines. Then we have a piston which has 9 mm dia of the foot land, and this is of a stainless steel hardened thing. So those things are also standardized the way it is been said. Apart from this, we need to apply a weight. So a dead weight of 2.16 is provided, and then we need to start the test. Now we are opening this. So this cover is provided to as a safety feature for this weighing balance, because it is very sensitive. Now we need to discard the first sample, and we'll start considering the next. The first is this. I've set the time for it. So it is showing 6, 5, 4, 3, 2, 1, and it will cut the sample, and it will fall on the weighing balance, and we will acknowledge. We'll show the MFI of the sample. So here it is showing the time after completion of the specific time. The cutter moves, and it will show here that what is the weight taken by the weighing balance, and it will automatically calculate MFI. Now it has taken the weight. We'll acknowledge it, and we can see automatically the MFI is shown for the sample. So it is showing 1.7. Test cycle, it is showing that the number of cycle I have set, now only one cycle is left, so that again the sample will fall, and we will take the results. We have taken first sample with the 1.9, second 1.7, again we will take one more, and then we can see automatically the average will be provided to us. So it is taken. We'll acknowledge, and it is showing the MFI of the sample. So here we are completed with the thing. Now we will go to the result section. We can see the number of results we have received. So first two sample I have discarded, so that it is showing. For other three, you can see what it is showing. 1.9, 1.7, 2. This is the melt flow rate of the sample, where average, MFI, the minimum, maximum, everything will be saved, and you can see what is the MFI of the sample. And in the history section, you can get all the results. You can take out in the PDF format. So in a digital model, you will not get the access to automatically calculate the result, and you will not be able to save the things. So here you will have a proper MFI value, weight, minimum, maximum thing, and you can take out the data in USB. So these facilities are provided in the Melt Flow Index Neo 2.0 model, where the manual intervention is focused to be as less as possible. Thank you so much.